Imagine looking at something so far away that it takes light over 5 hours to travel from there to your eyes. Now imagine seeing that distant world more clearly than we've ever seen it before. That's exactly what just happened with Pluto, and the images the James Webb Space Telescope sent back are absolutely mind-blowing. What you're about to learn will completely change how you think about our solar system's most mysterious dwarf planet. The James Webb Space Telescope, the most powerful space observatory ever built, has been quietly studying Pluto for months. And the results? They're nothing short of extraordinary. But here's the thing that's got scientists around the world talking. These aren't just pretty pictures. What Webb discovered about Pluto is rewriting everything we thought we knew about this distant, frozen world. We're talking about discoveries so significant that they're forcing us to completely rethink what's happening at the very edge of our solar system. You remember Pluto, right? That little world that used to be our 9th planet until scientists decided to call it a dwarf planet back in 2006? Well, it turns out Pluto has been hiding some incredible secrets all this time. And now, thanks to Webb's incredible infrared vision, we're finally getting to peek behind the curtain. Let me take you on a journey to the very edge of our solar system, where temperatures drop to minus 375 degrees Fahrenheit, where a day lasts longer than a week on Earth, and where we've just discovered something that has scientists completely amazed. Pluto sits about 3.7 billion miles away from the Sun. To put that in perspective, if Earth were the size of a marble, Pluto would be about 50 feet away. It's so far out there that when NASA's New Horizons spacecraft flew by in 2015, it took over 9 years to get there. That was the first and only time we'd ever seen Pluto up close, and those images were incredible. But now we have something even better. The James Webb Space Telescope launched on Christmas Day in 2021, and it's been changing everything we know about space ever since. This isn't just any telescope. It's a technological marvel that cost $10 billion to build and deploy. Its mirror is so large and so sensitive that it can detect heat from a bumblebee on the moon. And when it pointed its incredible sensors toward Pluto, what it found blew everyone's minds. Here's what makes Webb so special when it comes to studying Pluto. Unlike other telescopes that see visible light, Webb sees infrared light, which is basically heat radiation. This means it can see things that are completely invisible to our eyes and even to other telescopes. When Webb looks at Pluto, it's not just seeing the surface. It's seeing the temperature patterns, the chemical composition, and even the atmosphere in ways we never could before. The first thing Webb noticed about Pluto was something completely unexpected. The dwarf planet has what scientists are calling a new kind of climate unlike anything else we've seen in our solar system. Remember, Pluto is incredibly far from the Sun, getting only about 1,000th of the sunlight that Earth receives. It should be a dead, frozen rock floating in the darkness. But that's not what Webb found. Instead, Webb discovered that Pluto has an incredibly active and complex atmosphere. We're talking about layers of haze that stretch high above the surface, creating what scientists describe as almost like a blanket around the entire planet. But here's the really wild part. This haze isn't just sitting there doing nothing. It's actually cooling Pluto down even more than it should be. Think about that for a second. Pluto is already one of the coldest places in our solar system. But its own atmosphere is making it even colder. It's like the planet is wearing a coat that somehow makes it freeze more instead of keeping it warm. This discovery is so unusual that scientists had never seen anything like it before, anywhere in our solar system. But wait, it gets even more incredible. Webb didn't just discover this strange cooling effect. It found that Pluto's atmosphere is doing something that sounds like science fiction. The planet is literally losing pieces of itself to space, and some of those pieces are being captured by its largest moon, Charon. Picture this: methane and other gases are being pulled right out of Pluto's atmosphere and drifting through space until they get caught by Charon's gravity. It's like Pluto is slowly feeding its moon, sharing its atmosphere across the vacuum of space. This kind of interaction between a planet and its moon has never been observed anywhere else before. The images Webb captured show this process happening in real time. You can actually see the gases flowing from Pluto toward Charon. It's one of the most beautiful and mysterious phenomena scientists have ever witnessed in our solar system. And it raises so many questions. How long has this been happening? Will Pluto eventually lose its entire atmosphere to Charon? What does this mean for other small worlds in the outer solar system? But the atmospheric discoveries are just the beginning. Webb's infrared vision also revealed something incredible happening on Pluto's surface. The dwarf planet isn't the static, unchanging ice ball that many people imagine. It's actually incredibly active, with seasons that cause dramatic changes across its surface. We knew from New Horizons that Pluto has vast plains of nitrogen ice, towering mountains made of water ice, and complex terrain that looked surprisingly young and active. But Webb showed us that these features are constantly changing. The telescope observed what scientists call seasonal cycles of volatile ice redistribution. In simple terms, Pluto's ice moves around its surface as the seasons change. Now, when I say seasons on Pluto, I'm talking about something very different from Earth's seasons. Because Pluto is so far from the Sun and takes 248 Earth years to complete one orbit, a single season on Pluto lasts about 62 Earth years. But even with these incredibly long seasons, Webb could detect changes happening right now. The telescope found areas where nitrogen ice is sublimating, which means it's going directly from solid ice to gas, skipping the liquid phase entirely. This gas then travels through Pluto's thin atmosphere and condenses back into ice somewhere else on the surface. It's like Pluto is constantly reshaping itself, moving its ice around like a slow-motion weather system. What makes this even more fascinating is that Webb detected faint changes in Pluto's ice reserves that suggest the planet might have current geological activity. We're not talking about volcanoes or earthquakes like on Earth. Instead, we might be seeing evidence of cryovolcanoes, which are volcanoes that erupt with water, ammonia, or other liquids instead of molten rock. The idea that Pluto might still be geologically active is revolutionary. For decades, scientists assumed that small worlds like Pluto would be dead, frozen solid all the way through. But if Pluto still has geological activity, it means there might be liquid water hidden beneath its surface. And where there's liquid water, there's always the possibility, however remote, of life. Webb also made some incredible discoveries about Pluto's composition that are changing how we think about the formation of our solar system. The telescope's detailed analysis revealed that Pluto has a much more complex chemical makeup than we ever realized. The surface isn't just made of simple water ice and nitrogen ice. Webb detected traces of methane, carbon monoxide, and other organic compounds. But here's what's really exciting. Some of these organic compounds are being created right now by chemical reactions in Pluto's atmosphere. When cosmic radiation and solar particles hit the methane in Pluto's atmosphere, they create more complex organic molecules. These organic molecules then fall down to Pluto's surface like a gentle organic snow. Over millions of years, this process has been building up layers of organic compounds on Pluto's surface. It's like the planet has been running its own chemistry lab for billions of years, slowly building up more and more complex molecules. This discovery has huge implications for astrobiology, the study of life in the universe. While Pluto is far too cold and has far too little energy to support life as we know it, these organic compounds could be the building blocks of life. If similar processes are happening on other worlds in the outer solar system, places like the moons of Jupiter and Saturn, it could increase the chances that life exists somewhere else in our cosmic neighborhood. The quality of Webb's images of Pluto is simply breathtaking. Remember, Pluto is so small and so far away that even our best ground-based telescopes can barely see it as more than a point of light. The Hubble Space Telescope could make out some surface features, but they were fuzzy and unclear. Webb's images, on the other hand, show Pluto in stunning detail. You can see the boundary between different types of ice on the surface. You can see the towering mountains and deep valleys. You can even see the subtle color variations that tell us about the different chemical compositions across Pluto's surface. But perhaps most remarkably, Webb can see Pluto's atmosphere in a way that no other telescope ever has. The infrared images show the layers of haze stretching high above the surface, creating an almost ethereal glow around the entire planet. It's hauntingly beautiful and scientifically invaluable. These images are so detailed that scientists can now create accurate maps of Pluto's temperature variations across its surface. They can see which areas are slightly warmer or cooler and track how these temperature patterns change over time. This information is crucial for understanding how Pluto's complex climate system works. One of the most surprising things Webb discovered is that Pluto's atmosphere is much thicker and more complex than anyone expected. Based on the New Horizons flyby, scientists thought Pluto's atmosphere was extremely thin, about 100,000 times thinner than Earth's atmosphere. But Webb's observations suggest that the atmosphere is more substantial and plays a much more important role in Pluto's climate than previously thought. The atmosphere has multiple layers, each with different chemical compositions and temperatures. The upper atmosphere, where the haze forms, is particularly interesting because it's where most of the chemical reactions are happening. This is where cosmic radiation breaks apart methane molecules and creates the organic compounds that eventually fall to the surface. Webb also discovered that Pluto's atmosphere changes in ways that follow patterns we've never seen before. The thickness of the atmosphere seems to pulse, getting thicker and thinner in cycles that might be related to Pluto's complex orbital pattern. Pluto doesn't have a circular orbit like most planets. Instead, it follows an elliptical path that sometimes brings it closer to the Sun than Neptune. These orbital changes affect how much energy Pluto receives from the Sun, which in turn affects its atmosphere. When Pluto is closer to the Sun, more ice sublimates into gas, making the atmosphere thicker. When it's farther away, the atmosphere gets thinner as gases freeze back onto the surface. Webb is giving us our first detailed look at this process in action. But here's something that really shows how revolutionary Webb's observations are. The telescope didn't just look at Pluto by itself. It also studied the entire Pluto-Charon system as a unit, and what it found challenges our understanding of how moons form and evolve. Charon is unusually large compared to Pluto. While most moons are much smaller than their parent planets, Charon is about half the size of Pluto. This makes the Pluto-Charon system almost like a double planet rather than a planet and moon. Webb's observations show that this unusual relationship has created some unique dynamics. The transfer of atmospheric material from Pluto to Charon that Webb observed is just one example. The telescope also found evidence that the two worlds might be tidally locked not just in their rotation, but in their atmospheric and geological processes as well. Changes on Pluto seem to trigger responses on Charon, and vice versa. This discovery is making scientists rethink how binary systems like this one form and evolve over time. It might also help us understand other unusual pairings in our solar system and beyond. The technological achievement represented by these observations can't be overstated. Pluto is so far away and so small that observing it in this kind of detail requires pushing the James Webb Space Telescope to its absolute limits. The fact that we can see atmospheric layers, surface composition, and dynamic processes on a world nearly 4 billion miles away is a testament to human ingenuity and our relentless curiosity about the universe. Webb had to stare at Pluto for many hours to collect enough light to create these detailed images. Because Pluto is so faint and so far away, the telescope had to be incredibly patient, slowly building up each image photon by photon. It's like trying to see a candle flame from thousands of miles away while wearing sunglasses. The fact that Webb succeeded in this challenge opens up incredible possibilities for studying other distant worlds. There are hundreds of other dwarf planets and large asteroids in the outer solar system that we've never seen in detail. If Webb can study Pluto this thoroughly, it might be able to give us similar detailed looks at places like Eris, Makemake, and Haumea. Each of these worlds likely has its own unique story to tell about the formation and evolution of our solar system. Some might have atmospheres like Pluto. Others might have entirely different surface compositions or geological processes. Webb is giving us the tools to explore these distant worlds without having to wait decades for spacecraft to reach them. The timing of these discoveries is particularly exciting because they come at a moment when our understanding of planetary science is evolving rapidly. Just a few decades ago, we thought of the outer solar system as a cold, dead region where nothing interesting happened. Now we know it's full of active, complex worlds with their own weather systems, geological processes, and chemical evolution. Pluto's story is part of this larger revolution in our understanding. Every new detail Webb reveals about this distant world helps us piece together the bigger picture of how our solar system formed and evolved over billions of years. The organic chemistry happening in Pluto's atmosphere, for example, might be similar to processes that happened on early Earth. By studying how these reactions work in Pluto's extreme environment, we might learn something about how life's building blocks form naturally in space. The atmospheric dynamics Webb observed on Pluto also have implications for understanding exoplanets, planets that orbit other stars. Many of the exoplanets we've discovered are small, cold worlds that might have similarities to Pluto. The more we understand about how Pluto's atmosphere and climate work, the better we'll be able to interpret observations of these distant worlds. But perhaps the most important thing about Webb's discoveries is how they remind us that the universe is full of surprises. Even in our own solar system, and places we thought we understood reasonably well, we're still finding phenomena that completely overturn our expectations. Pluto was supposed to be simple, a frozen rock at the edge of our solar system, barely worth calling a planet. Instead, we've found a world with active geology, complex chemistry, dynamic weather, and interactions with its moon that we've never seen anywhere else. It's a reminder that every world in our solar system has its own unique story, and we're only just beginning to read those stories. The images and data Webb has collected will keep scientists busy for years to come. Every detail in these observations will be analyzed, modeled, and compared with other worlds to help us understand the underlying physics and chemistry that shape planetary evolution. But beyond the scientific value, these discoveries capture something essential about human nature, our need to explore, to discover, to push the boundaries of what we know. Pluto represents the edge of our solar system, the boundary between the known and unknown. Every new detail we learn about this distant world extends that boundary a little further. Looking at these incredible images from Webb, it's impossible not to feel a sense of wonder about the universe we live in. Here's a world so far away that it would take a spacecraft nearly a decade to reach it, and yet we can study its atmosphere, map its surface, and watch its seasons change from the comfort of our own planet. The James Webb Space Telescope has given us more than just stunning images of Pluto. It's given us a new perspective on what's possible when we combine human curiosity with incredible technology. These observations represent the cutting edge of what we can achieve when we dare to look deeper into the cosmos. As we continue to analyze Webb's discoveries about Pluto, one thing is certain: we're going to keep finding surprises. Each new observation raises as many questions as it answers, pushing us to look even deeper and think even more creatively about how our solar system works. The story of Pluto is far from over. In fact, thanks to Webb, we're probably just beginning to understand this fascinating world at the edge of our cosmic neighborhood. And who knows what other secrets are waiting to be discovered in those distant, frozen reaches of our solar system. These discoveries about Pluto remind us why space exploration matters. It's not just about satisfying our curiosity or developing new technologies. It's about understanding our place in the universe and appreciating the incredible complexity and beauty of the cosmic environment we're part of. Every time we learn something new about a world like Pluto, we learn something new about the processes that shaped our own planet and made life possible here on Earth. We're all connected by the same fundamental physics and chemistry that govern everything from the smallest molecules to the largest galaxies. The James Webb Space Telescope's observations of Pluto represent a new chapter in the human story of exploration and discovery. They show us that no matter how far we've come, there are always new frontiers waiting to be explored, new mysteries waiting to be solved, and new wonders waiting to be discovered. If these incredible discoveries about Pluto have amazed you as much as they've amazed me, make sure to hit that like button to help more people discover the incredible science happening at the edge of our solar system. Share this video with anyone who loves space and astronomy, because discoveries like these deserve to be celebrated and shared with the world. And don't forget to subscribe and ring that notification bell, because Webb is just getting started. This incredible telescope is going to keep making groundbreaking discoveries for years to come, and you won't want to miss a single one. From distant galaxies to mysterious exoplanets to the hidden secrets of our own solar system, Webb is opening up the universe like never before. What do you think about these amazing discoveries? Are you surprised by how active and complex Pluto turned out to be? Let me know in the comments below what aspects of Pluto's story fascinate you most, and what questions you'd like Webb to answer next. The conversation about these incredible discoveries is just beginning, and I'd love to hear your thoughts about what we might find as we continue exploring the outer reaches of our cosmic neighborhood.